Hi students, hope you all are doing well. Welcome to another very exciting session of healthcare entrepreneurship. So let's get started from where we left last time. So let's look at the list of hypotheses week wise. So the first set of hypothesis was an easy to use, right? This is all built around the value proposition. Just take a look at the value proposition. Easy to use, which is basically you can take a selfie. Useful means dynamic tracking of obesity. Sometimes if you take selfies 5 times a day, it will keep on telling you that you are almost getting to that point of obesity, or you are taking the measurements, let us say 5 times a month, and all of a sudden this certain date an alert comes that now you look very obese, right. So please take care of your weight. And convenient, which is use anytime, no visits to the clinic required and no instruments are required. So easy to use, useful and convenient, these are the three value propositions here. Face to fat app will be valuable for general public. So this is the hypothesis first, that these are the value propositions which would be valuable for the general public. The next is the same easy to use, useful and convenient face to face fat app will be valuable for doctors to reduce their efforts. So doctors do not want to now check the weight and height and other things. Now they can quickly have this app being referred and know the numbers, right. These hypotheses will basically help with the understanding of the value proposition, the customer segments. Who are the key customer segments? Is it the doctors or is it the general customers? Who are more enthusiastic? Third is channels. Through which channel can you actually go through? Is it the doctor's channel or go directly to the customers through the app? And the customer relationships. How can this get viral or get popular, right? Then once you have done this first 2 to 5 or 6 weeks of due diligence to understand this value proposition and get all this value proposition, customer segments, channels and customer relationships sorted out in your value business model canvas, the next thing you do is this third hypothesis, which is this target customers will be interested in paying for this app or referring to others. This will help you understand revenue streams, key resources, key partners, key activities and the cost structure. So let us assume the doctors are really interested. Now you know the revenue stream is through doctors referral, you know the key resources are to tie up with the hospitals, and the key partners here are the hospitals, and the key activities are basically focusing on the marketing with the hospitals, and the cost structure is basically running the referrals and have the hospital built like after a certain while. If this was the case with just the end customers, let us say doctors are not interested, then all these aspects change. So just through the third hypothesis we are trying to kill 1, 2, 3, 4, 5 birds with one stone, right. So just with a few set of hypotheses we can have a range of interviews to understand all our key details in the business model canvas. So in the business model canvas we have now turned everything into facts, where the ease of use, usefulness and convenience still stays as the topmost value propositions. We have therefore guessed it right and they are properly validated based on the customer discovery. The second is the customer segments. We have realized it is not the general public, because through the interviews what we realized, many of the general public just do not care about knowing about their obesity level. That is something which will make them anxious, and this is something which they would not like to use their selfies for understanding their BMI on a day to day time. So our initial assumption that this new technology is going to be so beneficial for so many general public has gone wrong. So many of these things will happen to you also as an entrepreneur, so please do the customer discovery. So what we did find out from here are the doctors are extremely enthusiastic about this kind of an app, and so are the hospitals, right. So the third point here is the channel has now changed from B to B from B to C. So we are now trying to pitch towards business to business, where business is from our company to the hospitals rather than the customers. Fourth, the customer relationships are going to be from word of mouth, but not through ads and social media, but through doctor's referral. Think about how much money can I save by knowing this or getting the right customer discovery. Otherwise what I would have done, and so many entrepreneurs do, is keep on running ads for thousands and lakhs of rupees, and you are just wasting your resources because you have not tapped what is going to be the right customer relationship. So here we have done the due diligence, has saved so much of money and time. Now we know only through doctors referral, so we have to just go convince the doctors and present this thing to the doctors, and we should be taken care of, right. Fifth point, revenue streams are going to be through the paid app, through tying up with the hospitals, and then possibly selling it to the company which is going to be hospital, right. So there has been instances, some of the hospitals have been so enthusiastic, they were like, whenever you are ready with this app, please let us know, we would like to buy it if this works really fine, right. That's an option already there. Sixth is the key resources. We realize manpower is definitely the key resources still. The second is the intellectual property. Intellectual property was third earlier, it has become more and more important. So many of the competing hospitals, they may want to steal this particular idea and have another app developer build it very easily, right. That is what we realized during the customer discovery, or while speaking with several hospitals, several of those were very enthusiastic. So now we got an inclination through this feedback which we would have never known earlier. Only through this customer discovery and interviews we realized so many hospitals are now interested, so probably I need to protect this technology. Social media of no use, right, like very little use. I would not say of completely no use, but it is lower in the key resources platform, at least not in the main. Key partners are the doctors and hospitals, very clearly. The key activity is not marketing but referrals. So we would have saved so much money of marketing. Think about you as an entrepreneur, you are very ready to go in the market, you do all sorts of marketing, wasted lakhs of rupees not doing the customer discovery. So this is where I encourage all of you to please do the customer discovery. You will find the right facts for the initial guesses, right, based on your discovery. And the last point is cost structure. Manpower is still the highest component contributing to the cost structure, followed by the software / hosting, which is going to be effective, and the third, ads, is non-existent, right. Ad is not very important. So this is part of the ongoing testing on the Indian population, where we are looking at the face to fat application. This is part of the research where basically so many people, we have hundreds of not really patients, these are human subjects with different levels of obesity and different levels of BMI. So basically they typically go in a clinic where they get body fat measurement through techniques such as BFM, like body fat mass, PBF, percentage body fat. These are some measurements which are done clinically. And then you have some anthropometric measurements which are basically based on some external measurements like weight, height, BMI, WHR, waist to hip ratio. They tie a kind of measuring tape and look at it. That is typically what is done, but here all of this can be avoided. So this is the different stages. You have an image, then it is sized. So once the selfie is taken, there might be that there is a certain rotation to the face. So there is an auto rotate function numerically or mathematically which brings the face here. It kind of curves it with a certain curve, and then there is a grid application, and then it curves it, and the grid basically allows for the curves to be attached to points. So now if we can have points like 1, 2 or 3, 4, then we know how the curve looks like. Finally, the curves are plotted here. You are looking at the right. So all these curves are now basically characterized or fit with certain standard equations, parabolic equations. Based on these parabolic equations, now you have face to fat correlations, right. So you are basically looking at two plots here. First is a BMI versus parabola coefficient, where we see 0.7688 correlation with between BMI and parabola coefficient. That means if you know the parabola coefficient, you will be able to very easily predict the right BMI. Another example here is we also compared the correlation of percentage body fat with parabola coefficient, which turns out to have a little lower correlation. So percentage body fat is still a good number, but we know that is not necessary. So now just with parabola coefficient we can quickly find the BMI by backtracking, right. So that brings us all these examples and going through the business model canvas and understanding how to convert guesses to facts brings us to one of the most important concept in this course, which is on minimum viable product. So, or known as MVP. MVP by definition is an idea or product designed with only a basic set of features to help you test your ideas in a chosen market. So, minimum viable product does not have to be a physical product, right? It is the basic set of features or some details which you find from your customer discovery and your business model canvas, where you want to test certain things in a market in a very cost effective and time effective way and get the right answers to make sure you can build your product right. It is a fast, cost effective way to test the demand of your product before it goes out in the market. So, you want to make sure that your product has some demand, right. So, MVP is typically centered around the different gain creators and the painkillers. So, the central heart of MVP is the value propositions, and you have several components surrounding it, and of course, there is the target customer. A very classic example is Airbnb. So, Airbnb, we are all aware of, it's one of the rent out places where it could be a house or a huge bungalow owned by somebody, and it is rented out to general customers who are tourists and whatnot. So, Airbnb did not start like that, right? Like they did not take over so many houses and then started their operation, right? So, what they did was they initially did a customer discovery. So, seeing an opportunity and needing rent money, Airbnb founders rented out actual air mattresses in their apartment, proving that guests would stay with hosts. So, typically back in the day, nobody would want somebody to intrude into their houses. So, for example, you are living in a 3 BHK house, would you like to host somebody who is coming from somewhere else and basically just sit there and basically spend their entire day? You do not know the safety aspect and other details there, right? You do not want that kind of a customer to sit there. But Airbnb changed that concept by actually proving. What they did was they rented their own house, put some air mattress, and just saw if them as a host and some people coming in as guests, do they comply well? Are everything safe, or is it a nice experience for those people? So, once they did this test on several of the places which they had, now they know that their business concept is something which is going to be valuable. So, this was their minimum viable product. This is this test dummy which they used with minimum cost and price, right. Another very popular example is Dropbox. So, a very classic example of MVP, Dropbox, many of us may be aware of. Before having Dropbox, we had this huge issue of storing every detail into a pen drive or a floppy disk or a CD drive, and we would then take it to another device and change it and update that. Dropbox was the first time which made it popular, where you can basically edit something somewhere and it automatically reflects in the other computers or folders, right. So, Dropbox makes it possible for you to edit files on your desktop and seconds later updates that file in all of your devices, be it on the mobile phones and other places. The founders did not dive straight in and release the product straight away. The MVP or minimum viable product idea here was to create a short descriptive video. So, minimum viable product can just be a nice description of through a video of what you are trying to build in terms of a product or a service, right. You can have nice presentation slides with a video. This is a very classic video. The YouTube link is provided here. You are welcome to look it up. Just a very short video. This video all of a sudden drove hundreds of thousands of people to the website. Huge fan following, and Dropbox currently is valued much over $10 billion, which I would say. And many of the new service providers like Google Drive and other things have replaced it, but there is still a market, and Dropbox is one of the first movers here. So, this is a classic example of an MVP. So, minimum viable product is some form in which it can be a PowerPoint presentation also, through which you can showcase your idea, your product or service idea to somebody and get a feedback and conduct a customer discovery. So, that is what a minimum viable product is. There are two types of MVPs in the market. The first type is known as a low fidelity MVP, second is high fidelity MVP. Low fidelity is something which is typically in order to gain a better understanding of your customer's problems. So, you do the customer discovery, you basically check on how valuable a solution to this problem may be for the customers. So, this is again part of the customer discovery. Investigate as to whether or not the problem is worth solving. So, sometimes you may think that your product or service idea is so great, but you may find out through the customer interviews that this is not very important. Explore what kind of solution would be the most effective for the customers. This is from understanding the value propositions. So, low fidelity prototypes, some of the examples are through surveys or customer interviews. This is a low fidelity prototype, again it is a small MVP. Through blogs, forums, a nice landing page or one page website or explainer video. Many a times some of the new products or services will just have a nice simple video to present them. High fidelity prototypes or high fidelity MVPs are typically a little higher version where you have some design or some physical component to it, or they could be digital prototypes where you are trying to look for early adopters who will be your first customers and help spread the word about your product. So, you cannot reach with a PowerPoint presentation of this great product which you are building and assume that people are going to pay for it, right. That is not very fair or intuitive. But if you showcase something which is 3D printed or molded or built by paper or pen, something like that, which you can actually showcase to people, they can touch and feel, that is something they may be willing to pay for in a later duration when you fully launch the product, or it is a pre-launch of the product. So, high fidelity MVPs are much more to find early adopters. They also help you define and optimize your business model. So, you can get very constructive feedback rather than some vague feedbacks when you just present a video or just present a PPT. You can also identify the best potential growth strategies through showcasing of a high fidelity MVP. Some of the different forms of high fidelity MVPs include digital prototypes, some designs or SolidWorks based design, 3D models of something, beta testing based models, crowdfunding. Crowdfunding is an example. It's one of the funding avenues I am going to talk at length in the upcoming lectures. Look up Kickstarter as a homework. Kickstarter and Indiegogo, INDIEGOGO and KICKSTARTER. These are typically platforms through which lot of people like us, lot of entrepreneurs like us or to be entrepreneurs like us test their high fidelity prototypes through this kind of a platform where they have a nice video with some tangible products which they have some offering and features, and they want to get some early adopters, pay some funding all across the world. Just look this particular forums up. I am going to talk at length about these forums. So, the two examples I want to take about the low fidelity and high fidelity stages like which we have just talked about. The first example is this slip testing device we have been talking about. The high fidelity of version of this was basically the surveys and customer interviews were conducted during this low fidelity phase of this, right. So, the value proposition guesses were tested and we found out low cost, portability and accuracy were the key idea. So, at this stage we had just presented the idea of, we had not presented the model in the term of this low fidelity prototyping or low fidelity MVP stage. Just idea, no model or product was showcased in this low fidelity customer discovery stage. However, at the high fidelity MVP phase, the 3D model was showcased, this 3D model on the left page, but it was still not a product. So, high fidelity does not have to be the final product, right. High fidelity can be the nice design which people can relate with. Earlier we were just throwing in ideas that this is what I want, this is how my dream house is going to look like, but now you have made the sketch of that dream house. Very similar for your healthcare product. Issues relating to existing products and how this MVP may solve those were discussed with shoe manufacturers as a part of this high fidelity MVP showcasing. The best potential growth strategies were identified, such as sale and rental opportunities. Let us go further. The second example which we talked about, this phase to fat, what did we do in the low fidelity initial customer discovery phase when we did the value proposition and target customers? We just ran surveys and we had the value proposition guesses which were tested, which is ease of use, usefulness and convenience. Again we had just the idea, no model, no product, no picture, right. We had just the idea and we wanted to test this idea during the initial customer discovery. In the high fidelity stage, human subject tests were conducted to test the concept but not the product. So we did not have the final product. We did different sorts of research to make sure if the concept is viable technically, right? A model app was developed to showcase to the customers, but did not have any science or product features. So we made a model app which just looked like a PowerPoint presentation. None of those buttons really worked. It's just different pages to look at, right? Like that, what my app is going to look like. So using templates such as Figma and PowerPoint, you can make such model apps. So the best potential growth strategies were identified through the doctors and hospital referrals. So in the high fidelity stage, again we did not have the final product, but it was a nice showcase of an app platform which we are envisioning to build, right? So this is how the low fidelity and high fidelity stages can be clearly distinguished. One is done during the initial value proposition and customer segment understanding, customer discovery, high fidelity prototype during the business model canvas filling, right? That is where we are doing the high fidelity prototype. So just to kind of conclude, the build phase, MVP or the minimum viable product basically refers to the building phase of a product while we are trying to go through the designing to the different stages of building. Deciding how complex and minimum viable product cannot be done through any formula. So we can never define this is how the MVP should be. Minimum viable product is something you can be very innovative, like I have given you several examples of low fidelity where you just have the idea, you can have a PowerPoint presentation. High fidelity is where you can have some design models or stuff like that. It requires a lot of judgment, that where exactly do you stand in terms of your entrepreneurial journey. When in doubt, simplify, make it very simple so that anybody with the least amount of intellect about your product can understand, right? Avoid overbuilding and over promising. So don't talk so flashily about your product or service that this is going to change the world, this is the next big thing. That is something which will end up in a tragedy, like we do not oversell or over promise. We are just trying to understand the customer feedback of our idea or the high fidelity prototype which we are trying to build. We want to hear from the customers what do they think rather than overselling. Any additional work beyond what needs to get you starting the loop might be a waste. So if you put too much of work, efforts and cost, it is going to be a total waste, right? So that is the idea of an MVP. Please work on your MVPs during your customer discovery and business model canvassing as two phases, low fidelity and high fidelity. Some last statements: an MVP does not speak to the product design and technical question, but also serves in testing fundamental business model hypothesis. So MVP will describe the technology, the product design, and also the first fundamental business hypothesis questions will be answered through the MVP. Thus, it serves in providing the needed dose of reality. So basically, it's a reality check for our product which we are trying to pitch as an entrepreneur, that whether this minimum viable product stands any ground in the market. If we are confident that it does stand ground, we have the full go ahead, let us build our entire product and start planning towards this possible prototyping and market launch, right? So welcome to another very exciting session of healthcare entrepreneurship. So we are right now in the design module and we are trying to get from the ideation to understand what are the different techniques of the design. We are trying to get towards the prototyping module where we'll be understanding more and more into how to convert certain designs into prototypes. So that's what today's lecture is about. It's into the product prototyping. So we will be talking about manufacturing and production. What are these terms specifically meaning, and how do they interact across each other, like in different disciplines such as healthcare, right? So let's get started. So what is a prototype? Prototype is basically a version which comes beyond the design, right? So you typically start with something which is known as wireframing, right? We had talked about wireframing where in the much more low fidelity stage, or you could say it like a middle fidelity or little below high fidelity range of MVP or minimum viable product, which we have covered in the previous lecture. That is where we do some sketching or wireframe, or we have some initial design concept of what we are trying to build, right? So it's a two-dimensional illustration of a product, which is typically a low fidelity MVP, right? Then we have another low fidelity MVP, which is typically a 3D illustration of a product that could be in form of a design, or could be in form of a 3D model. And then you have a prototype, which is basically a high fidelity MVP. So it's a full scale and functional form of a design. It doesn't have to have everything which you are going to offer to the customers at the very end, right? But it should have all the functional features and something which the customers can touch and feel and understand what your concept of the innovative product is, right? So now we have come from the design to the prototype, which is a high fidelity minimum viable product. And it is very beneficial for you as an entrepreneur to build a prototype with a given low cost and low amount of efforts, and basically take this prototype out there in the market to test and understand what the customers actually give, if what kind of feedback do they give. Do they want the design to look a little bit different? Do they want the features to completely change, or are there certain value points which they want to specifically mention, right? So there are so many aspects to the prototyping which comes into place. So while we make this transition from the design to a prototype, right? So here is an example of a smart watch where this was in an early low fidelity stage of just a sketch, which was converted into a design model and finally into a 3D printed prototype. Not all of this is 3D printed, but part of it. The casing is 3D printed, and then you have a dial and some screws and other aspects. But you could see it, it doesn't really look like a finished watch, like, or a product which a company would sell, right? So that's why it's called a prototype. It has some bare bones features, and it incorporates the design features, but still is a very crude model. So this is something which you can just touch and feel, but it's not the end product, right? So this is how the prototype of this particular smartwatch looks like, right? So aesthetically, is it super pleasing? Maybe not. You're probably going to put some really nice casing and other details, but those are separate. During the prototype building, you're not thinking of the final product or the aesthetics or how quickly I can manufacture 100 of these kind of things. We are not thinking. We are basically thinking of building something beyond the design which we can showcase to our customers, right? So let's go further. So what is the need for a prototype? Like I've already highlighted, it is to showcase to the customers. The customers would want to understand that what is your unique and innovative idea. Is it just all the same which was existing in other places, or is this something which is completely new? They want to touch and feel it in order to have a better thought process whether I am going to buy this particular device or not, right? So a lot of these monetary decisions, whether I am going to pay for this particular product or not, comes from actually touching and feeling, right? The design may not be good enough for them to give you the money, right? So entrepreneurship, as we had defined quite a bit, was basically an business model canvas formation. Like what we defined was, we want to impart or deliver some value to the customers, which are in the terms of value proposition, and have them pay for this particular value, right? So that is what we are trying to establish in a very concrete form through this prototype, right? So this particular prototype again is built with additive manufacturing techniques, and this which is primarily known as 3D printing, and this is one of the crude models, and you could see from the picture itself that this is not the finished product, right? This is something just to give you an idea that this is how the product looks like. Another type of manufacturing technique. So whenever we take the term manufacturing, let's define it, take a step back and define it. So manufacturing typically means you are trying to now go from the prototyping stage to a stage where you have finished products and you're trying to make tens and hundreds of it, right? And in order to do that, you have a requirement for certain resources, certain steps and protocols, and certain techniques, right, through which the device or the particular product is going through, right? So these are some of the manufacturing techniques which we are going to talk about in today's session. One of the techniques I've told is additive manufacturing or 3D printing. Many of us may be aware of it. We have heard of 3D printing somewhere. The other one, other technique which we may not be aware of that much, if we are not from the mechanical background, engineering background, is subtractive manufacturing. Subtractive manufacturing typically means that when we are eating out material from a particular material. So, additive is when we are adding material and building something, and subtractive is when we take out material. It's just a plus minus kind of. Yeah, negative is taking out material from an existing material to create something, create a product. So, here is an example where there is this nice kind of window based decoratives in a particular building which is built out of subtractive manufacturing, right. It's a layer wise cutting basically. So, we are going to get into the depth of what these techniques are specifically, right, as we go forward. So, before we do that, how to create a prototype? Typically, you would use one of these techniques, additive and subtractive, or a combination of both, right. So, these are the major two categories in which your manufacturing techniques would lie, right. Additive is much more recent, subtractive has been around for years, and there are a lot of specific manufacturing techniques which comes under the subtractive, and different types come under the additive as well. So, these are the two broad categories, right. So, these are one of the techniques which we would be using for our manufacturing of a prototype or to create a prototype. So, let us take a look. So, also just to acknowledge, we are talking about a prototype and then manufacturing, and then we have defined a prototype a little different from the manufacturing, right. So, when we talk about manufacturing, it is basically we sometimes use the word fabrication, or manufacturing is kind of interchangeably used. Manufacturing typically means when you are trying to build for some good amount of masses, right, it is beyond the prototype stage. But manufacturing techniques are used for fabrication and for building the prototype, right. Hopefully, that clarity is there. So, let us take an example of few of the processes here. So, you are looking at different scales of vision. So, when we say a macro scale is typically large in size, something which we can see and acknowledge. Micro is something which is very small, like the human hair, which you can maybe still see it or acknowledge, but many of these details you will not be able to see, like red blood cells. These are micro level entities, you cannot really see them, right. Micro electromechanical devices, right, MEMS, that's the broad term. So, these are typically in the sizes, order of sizes which are 10 to 100 microns or micrometers wide. Micro is like 10 raised to negative 6 meter. So, it is 10 raised to negative 3 millimeter, right. So, we are looking at 1000 millimeter is 1 meter. So, 1 millimeter divided by 1000 is micrometer, right. So, you are looking at a very small size. Usually human hair would fall typically around 60 to 120 microns, right. We call it micrometers or microns, right. Macro scale is typically in the order of millimeters or centimeters, meters, so which you can touch and feel, like if you are working with a mouse model to look at some form of clinical trial and whatnot. So, that is a macro scale entity. CD-ROM is again a macro scale entity, mobile phone is again a macro scale entity, right. Micro we have just discussed. Then there is another segment which is known as nano, and many of us may have heard about this nanoscale devices or nanotechnology, right. So many terms are floating around us. So, what happens with this nano is something which is 10 raised to power negative 7 typically. So, but you are looking at 10 raised to power negative 7 with this specific nano is kind of 1000 times lower than the micro, right. So, that is 10 raised to power negative 7 of this would be centimeters or something like, but it is typically like 10 raised to power negative 9 of meters, right. So, nano is typically very small. You are looking at virus particles which are typically at the nanoscales. So, you can think of COVID-19, this is a nanoscale virus, right, very small. So you could think of it could easily perforate through your masks, and there are clothings and whatnot. So that was one of the case study and details which were shared over the news back in the 2020-21. Those are in the nanoscale. Smoke particles, not the cigarette itself, but like smoke particles are typically in the nanoscales. Several proteins are in the nanoscale, right? So, what are the processes which you use in terms of manufacturing if you are trying to build something in macro versus micro versus nano, right? So, macro is very straightforward, you can touch and see it, so life is very easy. So, typically you would use rapid prototyping or additive manufacturing or 3D printing. These are the same terms for the same technology, which is 3D printing, sometimes known as rapid prototyping or additive manufacturing, right. So, here basically what happens is there is a basic block of something, it could be a metal block or a glass block or a wood block, and on top of it you are basically taking a plastic kind of material or some sort of material. There are several elastomeric materials as well, some material which can be with heat, which can change basically from the solid to the fluid state, right. So, typically that is the kind of material we are using for additive manufacturing or 3D printing. It is a solid filament wire of a certain diameter, typically of 1.7 millimeters or something like that, 1.75. And there is another few more sizes which are available. This is the most popular. You would get typically the filaments made up of PLA, which is a polylactic acid based filament, or there is ABS, which is acrylonitrile butane or something very similar chemical formula, I think. So that's for the ABS, right. And there are several other PET, PEEK, some thermoplastics. Then there are some other particular filaments which are built of composite materials. They are kind of made of glass fibers, and so many other techniques have come, carbon fibers and carbon nanotubes. So there are a lot of filaments out there, but the most basic ones are like PLA and ABS, right. So what do you do with these filaments? Whenever you apply heat, so more than, let's say, 210 or 230 degrees Celsius, based on whatever the particular melting ranges are. So, once you apply heat, then this particular filament melts, and then you kind of extrude it through an extruder, which is a narrow kind of funnel kind of extruder, which basically converges, and then you have a narrow tip from which you have the filament in the fluid form coming out or oozing out, right. And then you move a cursor. So, you have a set of motors and this extruder is placed in a sense that this could move horizontally as well as in both directions as well as vertically, right. Horizontal movement is for basically placing a layer of the particular filament. So, you can place one single layer, and then vertical movement is just to shift the layers. Now, you are in the second layer. Typically the layer heights are around in the range of 0.4 millimeters, or in some cases a little less, depends on the precision. There could be printers which are huge, like which has a precision of just 1 millimeter, right. But typically below 0.5 millimeter is a good number, and you will have printers with a precision which are very low in the almost micro scale, right. So, what you do is you create a layer, and then you move the cursor or move the extruder, create another layer, and you keep on building these different layers, and finally you get a product, right. The good part with additive manufacturing is internal very intricate features can be easily designed or modeled using additive manufacturing, because this is going layer by layer. So, this is not like it is creating from something from outside. It is creating layer by layer, and these layers are adhesively getting attached to each other due to the material, right. So, the material itself is like blending in, and it is creating that those set of layers. And finally, you have this nice product which is almost similar to the model which you saw, and now you can touch and feel. That's typically what is rapid prototyping. There are several options, and rapid prototyping has evolved over time. So you have 3D printers of different sizes. I'll be talking about the different diversities of 3D printers. You have them in different sizes, different speeds, different kind of filament materials, other features such as there is a bed, it has to be leveled, otherwise there would be some kind of an issue. So there are so many constraints around the 3D printing, so it is much more easy said than done, right? Like, it has a lot of maintenance based constraints, and the process itself is very optimized and complex, right? So companies take a lot of time to build a good quality 3D printer to make sure it's printing out all the models very nicely and to the right amount of tolerance, and it's not having some very sharp edges or weird edges coming out, or materials just filling in somewhere more, somewhere less. So these kind of things are avoided. You can also have multiple materials in a single model, right? So that's the description or outline of additive manufacturing or rapid prototyping or 3D printing. These are the same terms almost. The next technique is known as subtractive manufacturing. So subtractive manufacturing, what it does is, there is an existing material. So in rapid prototyping, you did not have any initial material, you are just using the filament, you just had a base, and base could be anything, it could be glass or wood. It's just a base to get you started, right? The base is not being used for any purpose. But in subtractive process, typically you have a material like steel or aluminum or some kind of there could be plastic based or Teflon based material, polycarbonate, there are a lot of polymeric based materials which are there, and typically this material is cut in different layers. So there is a cutter can have different precision, sizes, different ways of movement, but this cutter basically starts with the material, cuts it in one layer, goes down, cuts it in another layer, and keeps on cutting it down, right? So it's kind of a bottoms up and top to bottom, bottom to top kind of approach, right? So additive manufacturing, as we can all see, is a bottom to top approach where you're building like from the foundation to layers up, and subtractive manufacturing is a little opposite. You're basically cutting in from the top and coming below, right? So that's typically what subtractive manufacturing is. Sometimes it is known as precision machining, or terms like machining is being used. You may have heard the terms like CNC machine or milling machine, or some other lathe machines, or have ever used it as an engineer, or may have experienced it as a part of your immersion programs or whatnot. So that's where typically the subtractive manufacturing processes come into fruition, right? So macro scale, you can easily do 3D printing as well as subtractive or additive processes like additive manufacturing and subtractive manufacturing. These are much more easy, right? These are the two options, and typically using these, you would build a CD-ROM or a mobile phone, and these kind of details. There are several other molding options, like typically you may ask that, is this mobile phone built out of additive manufacturing? So typically it's not, it's some form of molding process, right? So these are some manufacturing process. In addition with this, there are several molding process like injection molding and other things which can quickly make an entire part without have to go layer by layer. So these techniques are very crucial in the sense that many of us who do not know too much about manufacturing can quickly use this technologies, subtractive and additive, to do a layer by layer system and to build our product, right? So this is for all the entrepreneurs, it's much more easier to use. But in many cases, if you are heavy on manufacturing side and you're trying to build a product which has to be mass produced and whatnot, you may get to injection molding and other techniques, right? So that's typically a mechanical engineering topic. So I'm just going to cover the length and breadth of it, not to the extent of depth of it, right? So next is in the micro scale, you are looking at basically some from the additive standpoint, you're looking at a technique known as this cold spray or spraying technique, through which you can have different layers, and basically there can be a powder which is formed in different layers, and the spray could either be working as an adhesive in that powder, which gives the adhesion, and the powder layer is kind of all set. as the new layers are getting built. So that's one technique. The similar subtractive process at the micro scale is usually a laser machining. So you use a laser beam to cut through certain products like majorly plastic based or polymer based materials. Some of the lasers would be usually very good for the metals. Rest of the standard lasers would not be that good, right? So laser machining typically has heat as a component, and like light heat. So basically you are heating and taking away material from a certain place, right? So this is from a micro scale standpoint. Let's look from a nano scale. So you have a technique from additive manufacturing standpoint, which is known as nanoparticle deposition, right? So you can have nanoparticles being deposited in different layers, and it's much more complex technology, right? Then there is a AFN printing. So there are so many other techniques in nanotechnology. This is just to give you an insight. So when we say additive manufacturing or a additive process, it typically does not only mean 3D printing, even though this is typically the term is used in the industry like such, that whenever you say additive manufacturing, oh, I'm going to do 3D printing, or this is rapid prototyping. These terms are actually having some different meanings, right? These are broad versus narrow categories. Then another technique in the subtractive process in nanoscale is focused ion beam. So focused ion beam can be used to make nanoscale indents or structures within a particular substrate or a base material, and you could use it for biosensors. You could use for several modifications in this, basically the molecule, cell structure and whatnot. So there are tissue engineering applications, drug delivery applications. So several things happen in the nanoscale as well. So this is kind of just giving you an overview of how additive and subtractive processes of different types fit into the macro, micro and nanoscales respectively. Let's look further. So additive manufacturing, as we always commonly call as 3D printing, let's take a look what this actually, what is the principle of this particular process, right? So from a definition standpoint, 3D printing, also known as additive manufacturing, is a method of creating a 3D product. 3D means something which you can see in 3 dimension. So if you take a piece of paper, it's a 2D product because it doesn't have depth, right? It may have a very small amount of thickness, so you could still think of it as a 3D, but typically I would think of a paper as a 2D, which doesn't have depth. It just has length and breadth, right? So that's a 2D product. So a design which you typically make or a design planner is kind of a 2D design, but whenever you have made a 3D model of something which has depth or thickness, that basically means it's a 3D product. So you're trying to build a 3D product using 3D printing, right? This is usually built layer by layer using a computer created design. So you can create a design on a computer, create a 3D model and 3D print it, or you can derive designs based on various imaging modalities. We have talked about it, like CT scan or MRI scan based, like brain models or organ models. This you can 3D print also directly without too much of work, right? So once your design is ready, 3D printing is basically taken care by the 3D printer. You don't have to hit your head around to really figure out how to do that, right? A few operations may be needed, but typically 3D printers are built around that process. So one of the most common type of 3D printer is known as FDM, or a fused deposition modeling, right? So fused deposition means basically this technique where you have this particular filament and you are trying to heat it and then have it in the liquid stage, and then that liquid kind of lays in form of that layer, right? So that's known as fused deposition modeling, right? FDM printer. The next is stereolithography. So stereolithographic SLA technique is basically when you are trying to use some kind of a mask or a stencil. Many of us may be aware of what a stencil is. You use typically a stencil to write A, B, C, D, E, F, G, H. make circles, different designs, right? We all remember. So stereolithography can think, we can start thinking about this in the form of a stencil. It's a much more precision stencil, in which that stencil is basically used in the sense that only certain places in a material is kind of hardened through using a laser or some technology, and so lithography is the technique, and basically through that you have layer by layer thing. Again, we are going to explain both these techniques as we go along. Then there are other techniques like DLP 3D printing, photopolymer phase change inkjets, which are polyjets, selective laser sintering, which is SLS. Many of these techniques like SLS and all are used at an industry level, where you need a very high precision of your products coming out, right. So if we take a look at the figure on the right, we are basically looking at a kind of a cup kind of shape, or some particular shape which is being built layer by layer, and you can see the extruder on the top, which is the kind of this golden color or coppery color narrow funnel, which is then at the very top. So that is the extruder, it is oozing out the material, and it is kind of circling around to put the layers, right. And if you look at the outside surface texture, you could see some textures. So typically these textures are coming due to the crudeness of the 3D printing process, which is basically the FDM process. So FDM does not produce very high quality surfaces, they are typically having some surface roughness, and usually very good for prototyping, but if you need a high precision part, FDM may not be the best technique to follow, right, in that particular case. The other techniques are selective laser sintering, plaster based 3D printing, where you have a powder bed and an inkjet head 3D printing, thermal phase change inkjets. Inkjet is something which we have heard quite often, right. We have used an inkjet printer at some point. So inkjet basically has a jet of an ink, and basically puts those kind of that ink is transferred to the paper. So very similar, there are certain inks which can be laid over in different phases as well, and different layers, right. Then you have another laminated object manufacturing, which is a LOM technique. It's another form of 3D printing, but the most popular ones are the fused deposition molding FDM and the stereolithography SLA, right. There is a YouTube video which you can watch. In the interest of time, I am not playing those, but there is a link here, basically you can look up, and if you just type 3D printing on YouTube, you will know exactly how a 3D printing process looks like. If you cannot find the right process, put FDM 3D printing, right, fused deposition modeling based 3D printing. This is what the case is, right, in this particular picture. So what is the principle of this fused deposition modeling? I have told you briefly, but this is the scheme of things. So you have a spool of filament, basically these are filaments, like you have a spool of wire, it is a spool of filament, basically kind of a plastic kind of feeling you get from that filament. It could be either from PLA or ABS, and then the filament is made of some form of thermoplastic material. So thermoplastic is basically a term. Plastic basically means something which can break or damage or change its form, right. Thermo is it change thermal, so heat, with heat it can change its form or phase, right. So this basically goes from solid to liquid phase when it is being heated. So acrylo nitrile butadiene styrene as the right word which I was trying to get at, which is known as the ABS, and polylactic acid is PLA. There are many other materials. So typically you have this set of gears through which this spool of filament is fed in. This is known as a feeder mechanism, right. So these gears kind of make sure there is a pulley and there is a gear, both kind of move in this direction, and basically you are trying to make sure that your particular filament is fed in at a much more slower rate. This feeding rate is usually crucial, because if you have a very high feeding rate, excess of material can get fed in, and you will not have a very good printing. Think about if you are putting too much of material coming in, then it will have a big puddle of material in a single layer and the finish would not be good, right. So, first of all this is optimize the speed of the feeder, right, speed, and sometimes we call it as a pitch of the feeder, that in every movement of the gear how much is it feeding in and at how much speed, right. Then this feeder the filament from the feeder basically gets fed within this particular extruder, in which this extruder is nothing but it is a heater basically. It takes up the temperature and takes it up to 200, 230 or something like that based on the material, and due to that the spool of material which is coming in gets melted, and there is a much more narrow opening, much more minute opening through which the material starts coming out. And while this is happening, the process on the right happens, which is basically you have a set of motors and belt and pulley mechanism which is moving this entire assembly of the extruder and the feeder mechanism around to make sure you lay different layers, right. So, let us take a look on the right figure. Basically you have the extruder and feeder assembly kind of represented by the purple purple block or purple shape specifically, which is shape number 1. Then you have 2 as these layers basically. So, these layers, as you can see, they are all coming in different layers and there are gaps, there are surface undulations and so forth. But on the grand scheme of things, these are very non macro scale gaps, so small looking gaps which you cannot really see from your naked eye. So, when you take a look at a 3D printed prototype, you would usually see it is fairly smooth, right, but it has some roughness to it, but you cannot specifically figure out those gaps because there are kind of micro scale gaps specifically. So, then you have this second one, which is the layers, and the third one is basically a base. So, there are cases in which the base kind of moves up and down to give the z axis movement as the layers kind of keep on building up, and there are cases where the extruder itself just moves up and down and the base is stationary. So, there are several techniques in which this 3D printers are built in the industry. Sometimes the bed is going up and down and sometimes the bed is completely stationary, and the extruder itself, the assembly of the extruder is moving with 3 different set of motors, x axis, y axis and z axis, right. Z axis is to place the different layers. So, with this I would like to thank you. This is all for the session. Hopefully you have learned something. We will see you next time for the next class, right. Thank you.